Good morning, sir. This is Himabindu from CSCA section. Today I am going to explain about concurrency execution and serializability in database management system. Concurrency execution and serializability. Introduction to concurrency execution. Concurrency execution allows multiple processes to run simultaneously in a system. It improves resource utilization and system throughput by overlapping operations. Understanding concurrency is essential for designing efficient multi-threaded applications. Here concurrent execution means process concurrent execution and interleaving. Process interaction models, parallel composition of asynchronous process interleaving, interaction state actions, process labeling and action relabeling and hiding structure diagrams. Practice multi-headed Java programs. Importance of concurrency. Concurrency enhances performance by maximizing CPU usage. It supports better responsiveness in user interfaces by preventing blocking operations. It is crucial for disturbed systems where tasks can occur in parallel across different nodes. Here, if you observe this diagram, here it is the task 1, task 2, task 3 and task 4. These tasks are performed with the help of CPU. Concepts of concurrency. Concurrency involves managing the access of shared resources by multiple processes. It relies on synchronization mechanism to prevent conflicts and ensure data integrity. Key concepts include threads, processes, logs, and semaphores. Here, if you observe these delegated to three workers. These three workers are shared with the shared state in memory. This shared state in memory is shared with the shared space in a database. Now, types of concurrency. There are two primary types of concurrency, coarse-grained and fine-grained. Coarse-grained concurrency deals with larger blocks of code, while fine-grained focuses on smaller sections. The choice between these types affects performance and complexity in system design. Modeling concurrency. Two types of concurrency. First one is system concurrency and second one is objective concurrency. Now what is system concurrency? Each object states diagram in executing concurrently with the others. Objective concurrency means an object can be partitioned into subsets of states, attributes and links such that each of them has its own subdiagram. The state of the objects consists of a set of states, one state from each subdiagram. States diagram are divided into subdiagrams by dotted lines. Next, challenges in concurrency. Concurrency introduces challenges such as race conditions and deadlocks. These race conditions occur when multiple processes access shared data simultaneously. Deadlocks happen when processes wait indefinitely for resources held by each other. Here, if we observe these diagram, concurrency problems in transactions. First, dirty read problem, unrepeatable read problem, lost update problem, and last one, phantom problem. Now, introduction to serializability. Serializability is a key concept in database management to ensure transaction consistency. Here, serializability is a key concept in our database management system. It defines a schedule as serializable if its outcome is equivalent to some serial execution. This concept is crucial for maintaining the integrity of database in concurrent environments. Here, if we observe this picture, serializability is a concept that helps us to check which schedule are serializable, why we need this. Why we need this serializability? A serializable schedule is the one that always leaves the database in consistent state. This serializability leaves the database in a consistency manner. Types of schedules in database management system are serial schedules and non-serial schedules. When we come to the serialized schedule, a transaction is executed completely before starting the execution of another transaction. If a transaction is executed completely before the starting of the another transaction is called serializable schedule. When we come to the non-serializable schedule, the serial schedule where one transaction must wait for another to complete its all operation. If one transaction should be executed, then the another transaction should be wait for until the first transaction should be executed. This type of execution of transaction is known as non-serializable schedule. Now, types of serializability. There are two main types: conflict serializability and view serializability. Conflict serializability means it focuses on the order of conflicting operations in transactions. View serializability ensures that all transactions see the same data as if executed in same serial order. Here the 19 types of conflicts: resolution complexity, high complexity, low complexity, reference frame, external, internal, arena, object, schedules, etc. Now, importance of serializability. Maintaining serializability guarantees that concurrent transactions do not lead to inconsistent states. It ensures that the database behaves predictability under concurrent access. Serializability is essential for applications requiring strong consistency such as banking systems. Serializability means two schedules are equivalent if they always have the same effect. A schedule is serializable if it is equivalent to some serial schedule. For example, if two transactions only read some data items, then the order is which they do it is not important. If T1 reads and updates X and T2 reads and updates a different data item Y, then again they can be scheduled in another any order. Now, achieving serializability. Serializability can be achieved through various concurrency control machines. Log-based protocols prevent conflicting transactions from executing simultaneously. Timestamp ordering ensures that transactions are executed in a global agreed order based on submission time. Here, if we come to the serializability or two types, one is conflict serializability and another one is view serializability. Locking mechanisms. How these serializability will lock? Locking is a common method used in database to enforce serializability. Shared logs allow a concurrent read access while exclusive logs prevent other transactions from accessing the data. Proper management of logs is critical to avoid deadlocks and ensure system performance. Here types of locking mechanisms are two types. One is shared lock and another one is exclusive lock. Here shared lock means S lock or read lock. These shared lock allows transactions to read but not update a record or other resources. Read but no update permitted. Used when just reading to prevent another user from placing an exclusive lock on the record. Here exclusive lock is also known as X locks or write locks. Prevents another transaction from reading and therefore updating a record until it is locked. No access permitted when used when preparing to update. Now, timestamp ordering protocol. Timestamp ordering assigns a unique timestamp to each transaction to determine the execution order. It allows transactions to be scheduled based on their timestamps, ensuring serializable results. This method helps us to avoid some issues associated with locking, such as deadlocks. Performance trade-offs. Implementing concurrency control machines can introduce performance overhead. Effective design requires balancing between concurrency and consistency to optimize performance. Understanding the trade-offs helps developers make informed decisions for system design. Here, power is related to performance, performance is related to area, and again area is related to power. This is the loop process. Real world applications for these serializability. Concurrency execution serializability are critical in various Real world applications. Examples include online banking, e-commerce, transactions, and real-time data processing systems. These applications rely on consistent and efficient handling of concurrent operations. Future trends in concurrency. The evolution of multi-core processors is pushing the boundaries of concurrency execution. Emerging technologies like cloud computing and microservice architectures demand advanced concurrency models. Future trends may focus on more sophisticated algorithms for managing concurrency and serializability. Here, if we observe this diagram, here there are four types of codes. One is catch. All are the four are catchy. These four codes are shared with attached to shared memory, and these shared memory is attached to bus interface. Conclusion. Concurrency, execution, and serializability are fundamental concepts in computer science. They play vital roles in ensuring efficient performance and data integrity in concurrent systems. A solid understanding of these topics is essential for developers working with modern applications. When we come to this diagram, parallel for core 1 and core 2, these are task 1 and task 2, and concurrent are core 1 and core 2, task 1, task 2, task 2, 3, and so on, task nn. And similarly, these concurrent code 2 is also same like that. Both concurrent and parallel are task 1 1, task 2 1, task 2 2. These like we have to define. Thank you, sir.